Okay, this is part 2 of our lesson on doing the basic trig identities. I'm just going to pick up where we left off. We did 4 examples for you. I want to do a few more here, and let's just play them out. Secrets again, know your trig identities. Writing stuff in terms of sines, cosines instead of the other functions. Just doing what you know how to do algebraic wise, common denominators, distributing, all that kind of fun stuff that we mentioned in the last video. Do that, practice it. The more practice you do, the better you're going to get at it. So again, I told you that typically it's good to take the ugly side and work on that to simplify. So I'm going to guess that this left side looks a little uglier than the right side, so I'm going to goof with this. Now, a lot of different ways you can go. Is one way more right than the other or more correct than the other? Not necessarily. There's many paths that'll take you to the same place. So, I mean, I could write this secant and this secant as 1 over cosines. I could distribute. There's a lot of ways I could proceed. I'm just going to go ahead and distribute. So I'm going to take this secant x times this secant x, which gives me a secant squared, and then distribute the secant times this cosine, giving me a secant x cosine x. Now, from here again, I can write this secant squared as 1 over cosine squared. I'm going to leave it alone for a minute, and I think you'll figure out why when I continue, when we go later on. This secant, however, I am going to write using the reciprocal identity, so I know that secant is really 1 over cosine. Purpose 4, why did I mess with this secant and leave this alone? Quite simple. When I turn this into 1 over cosine, this cosine on the bottom is going to cancel with this cosine on the top, leaving me with just this original secant squared minus 1. And the reason I mean, you can see why I turned this one into 1 over cosine in order to cancel those terms. But why I left this alone is because when I have a function squared, a trig function squared, and then some, kind of a combination of a 1 or a squared and a squared, typically these become trig identities, specifically Pythagorean identities. And I know that secant squared minus 1 is actually the Pythagorean identity for tangent squared, which is what I was trying to prove this equal to, so game over. Let's try number 6 here. What I have is a fraction on the left that I am trying to prove is equal to this thing on the right. Now, again, I know you look at it and you say, oh, look, it's a proportion like I did in geometry. I can cross multiply and solve. I'm not trying to solve for any variable. I cannot use properties of equality because in your geometry class where you're trying to solve for something, you knew these quantities to be equal. So you could use properties of equality. Here, I'm trying to show that they're equal. You cannot use that. So I know I've talked about this a lot, but it's a common error that I see people making, and I don't want you to do that. So cross multiply and see what happens. You're going to get your butt kicked. That's what's going to happen. So we need to go about other means. As far as the ugliness factor goes, I'm feeling this right side looks a little nastier than the left, so I'm going to take that ugly side and simplify it. So I'm going to start on the right side, and again, lots of ways to proceed. I'm just going to go and just be a hater on anything that's not a sine or a cosine. So this tangent, I'm going to turn it into a sine over cosine using my quotient identity. This secant x, I'm going to turn into 1 over cosine, and this cosine I'm going to leave alone. Now, what you have to kind of keep in mind as you're going through is that our ultimate goal is to do or to use whatever identities, whatever algebraic techniques are legal to use, and to try and get it to look exactly like this side. Mess with one side, show that it equals the other side. So my goal is to make this look like that. And right now, this does not look like secant over tangent, so we got a little work to do. So where did I go from here? Well, I left this sine over cosine alone. I left this 1 over cosine alone. So what did we do? Well, I took this cosine and put it over 1, but what I know is I cannot add or subtract fractions unless they have the same denominator, so I'm going to multiply by cosine over cosine, or by 1 in a useful way. And what's that going to do? Well, it's going to give me that common denominator of cosine here so that I can combine those two fractions. So 1 over cosine minus cosine squared over cosine. Again, leaving this top expression for tangent sine over cosine alone, I get 1 minus cosine squared over cosine. Now, where does this lead us? Well, 1 minus cosine squared, a 1 and a squared, a lot of times leads you towards a Pythagorean identity, and 1 minus cosine squared, which I have right here, that quantity is a Pythagorean identity for sine squared. So, what can I do from here? I have a fraction divided by a fraction. Algebraically speaking, I know when I do that, that dividing by a fraction is the same as multiplying by the reciprocal. So instead of dividing by sine squared over cosine, I'm just going to multiply by cosine over sine squared. The end result is that the cosines cancel. This sine cancels with one of those, leaving me with 1 over sine, which is nice and reduced. However, is it what I want? Remember back at the beginning of the problem, I was trying to show that it's equal to secant over tangent. That's not what we got. So, here's what I know. I know 1 over sine can be rewritten or simplified as cosine or cosecant x. But again, you have to approach this in, here's what I started with, how do I make it look like that other side? So I really need this to equal this expression secant over tangent, which I had on the left side. So what do? How do I turn a 1 into a secant? Well, I divide it by a cosine. But I can't just go dividing the numerator of a fraction by a cosine unless I also do it to the bottom. So I'm going to take this denominator and also divide it by a cosine. So what happens? Well, 1 divided by a cosine is secant, which I wanted, and sine divided by cosine is tangent, which I also wanted. So I get 1 over cosine divided by 1 or by sine over cosine, secant over tangent, which is what we're trying to prove. Let's do number 7 here. I have this expression on the left, tangent x plus cotangent x. They do not just simply cancel, being reciprocals because of the addition, equal to cosecant x times secant x. Again, just over time here, I found that it's a little easier to turn addition into multiplication than vice versa. I mean, I'm sure we can do it both ways, but I'm going to show you how to turn addition of two terms into multiplication. So, again, don't like tangents. Use your quotient identity. That's sine over cosine plus cosine over sine. Again, you're adding these quantities. You cannot cancel them. So where do I go? Well, I need common denominators. So this has a cosine. The other one has a sine, so I'm going to multiply the first fraction times sine over sine. Second one has a sine on the bottom. It needs a cosine, so I'm going to multiply by cosine over cosine. That'll give me common denominators, and will give me the expression sine times sine, which is sine squared, over our denominator, sine times cosine, plus cosine times cosine, which is cosine squared, over the same denominator. Once I have that, I have the common denominators. I can combine these two into one fraction, giving me sine squared plus cosine squared on top. Now from there, I know that sine squared x plus cosine squared x is a Pythagorean identity for the number 1. Again, it doesn't look like what I had in the beginning. I wanted to make it cosecant times secant, and that's not what I've got. Well, let's separate this. This is multiplication, so I can take 1 over sine times cosine and write it as 1 over sine times 1 over cosine. 1 over sine being the reciprocal identity for cosecant, and 1 over cosine being the reciprocal identity for secant, which is what we're trying to prove. Let's do one last one, and then we'll call it a day here. I want to prove that cotangent theta divided by secant is equal to cosecant minus sine. Again, my choice is going to be this. I'm going to leave the quotient or the division on the left. You might say it's in the uglier part, but again, I found that turning addition and subtraction into multiplication or division is typically an easier way. So I'm going to take this cosecant, use my reciprocal identity, and write it as 1 over sine, and then minus sine. I need a common denominator. This is technically over 1, so to get this denominator, I'm going to have to, again, leave the left side alone, leave 1 over sine alone. I'm going to take this sine and multiply it by 1, specifically sine over sine, to give me a common denominator with here. So what I'm going to get is 1 over sine minus sine squared over sine, which when put together with your common denominators gives me 1 minus sine squared, which is the Pythagorean identity for cosine squared over sine. And here's what I get, but it doesn't necessarily look like what I want it to. So we're not done. We have to goof with this a little bit more to get what we want. So what am I going to do? Well, I'm going to break this apart. Cosine squared can be written as cosine times cosine, and sine can be written as sine times 1. Now what does that do for me? Well, it gives me a cosine over sine, which your quotient identity says is cotangent, which is good because that's what I wanted. And then we're stuck with times a cosine. And that cosine we had at the end, right here, cosine over 1, the reciprocal of cosine is, or cosine can be rewritten as 1 over secant. So I get cotangent, which I want on top, times 1 over secant, which I have on the bottom. I get equivalent expressions, and we're done. Hope this helps a little bit.